Thanks so much for having me. Good morning, everyone. I hope you had a good social event last night, and thanks for getting up early to attend this keynote. Let's see if we can make this work. Looks good. So, it's my pleasure to be here with you today and to talk a bit about building data science tools from a geospatial perspective, because that's where I'm coming from. And when I wrote the abstract for this keynote, I was in a very excited frame of mind, coming back from all kinds of events where people were showing all kinds of AI tools. That's why I put that in the abstract. And I want to honor this initial idea, but I will make it broader, and this is not an AI talk. Actually, I just returned back from another Python and R and Julia event called Spatial Data Science Across Languages that took place in Salzburg like 2 weeks ago. You can see it was a nice little event workshop, very nerdy, with a couple of very nice people who are also in the space of developing spatial data science tools. And we had a series of discussions of how to interface, how to make things work for us as developers, but also for the users. And of course, AI was one of the big topics. Actually, it was the topic that started the first day of the discussions. And there was no real consensus about many of the questions. I think we're all still looking for answers like, is it a tool that will really simplify our jobs? And for some tasks, it might actually be. For others, there were some mixed results, of course, with it producing like just garbage. But definitely for some tasks, it might be a tool to simplify the job. But we also talked about that it looks like it will actually be more work for library developers. One of the most noteworthy things is, of course, if you get issues raised on GitHub that complain about stuff that is only a bug or doesn't work because the LLM used the wrong version documentation for the code library that is installed, and many other things. So one big challenge that comes from all these things is a new way is needed for how to teach future users, but also future developers, future contributors to these libraries in how they should approach, how they should work together with AI, even though there is AI. And this is something that we will need to explore in the future, maybe how to hold hands for people, maybe having an agents.txt that says, OK, read exactly this documentation to work with this version of the library, so forces a little bit to do the right thing. But it's definitely not yet cut and dry how to approach all these things. Why was I at this event anyway? My contribution to the discussion was mainly focused around the MovingPandas ecosystem that I'm developing, which comes from my line of research. So for a long time, I was like very focused on movement data analytics. So everything that is trajectories, every moving object in space, whether it be vehicles, people, animals, that's the kind of data that I'm building software for. And I released that as MovingPandas library a couple of years ago. And it's now an OSGeo community project. And I'm trying to build around that as well. And it was conceived reasonably long before the dawn of Gen AI, as were many other projects that do this kind of movement analytics stuff, and I've only listed a couple of them here. What I find really interesting is that almost all of them took off simultaneously in 2019. There must have been something in the air. I think it was GeoPandas that was in the air, which was getting really, really good. And everyone was like, OK, let's take it from here. Now we can actually do something. And we've been developing ever since. And you can see the growth here. So what does MovingPandas do, just in a nutshell? On the one hand side, it does help you with data exploration. So because it's spatial data and temporal data, there's a slight challenge of actually visualizing it. Of course, you want maps, but you also want to see the dynamics of the movements ideally. So data exploration is one thing. Data analysis, of course, is another thing. You want to be able to calculate speeds, directions, do, for example, extractions of stops, like you can see in the panel app on the right-hand side, which I have added as a demo here. You want to do certain data engineering and cleaning tasks, particularly if you're into machine learning. And you can build these nice visual analytics things like the stop detection app on the right-hand side, where you can play with different parameters and experiment how the results will look like when you force the stop detection algorithm, for example, to look for longer stops or shorter stops. This can be really useful to do. And we also want to leverage that in our research to build front ends for explainable AI, which is this approach of actually looking into machine learning models and even black boxes and trying to understand what's going on under the hood. That's also some place where we need these visualization options. And luckily, it's not just me who's interested in that, so I try to keep track of what other people are doing with the library, and luckily, at least the scientists, they do tend to cite the library, so I can have a look into what they're doing. Of course, lots of people do human mobility analytics, and a very popular algorithm is exactly the stop detection algorithm that I presented before. So this is something that I see a lot, people trying to find out where groups of people or individuals stop and what they might have been doing there. Another domain where I have published in the past was about analyzing vessel traffic, so ships on the seas, on the rivers, and that naturally brings people also to the library. So for example, to predict vessel arrival times at ports or at locks, that's another thing that I have seen people doing. And what they need to do there is they need to segment these continuous observations of a ship that might be traveling for weeks or months into individual trips between ports. So they also use this tool to perform these kinds of splits. And the most massive implementation that I'm currently aware of is this framework for analyzing drone movements. You can see here all the boxes from MovingPandas that they used, from splitting the continuous observations to visualization, aggregating, generalizing, smoothing the trajectories to remove all kinds of outliers that you get when you work with GPS signals. And of course, they also use the stop detector. That's an evergreen here. So it's definitely a library that developers enjoy using, but my goal in the last couple of years was to also bring it to the end users and how to make it more user-friendly. And that was before Gen AI was a thing. So what I'm going to talk about first is how to make these spatial data science tools more accessible on the one hand side for desktop GIS users, and on the other side for people who don't even want to install a desktop GIS, but who just want to use it in their browser with some cloud access. So that means for me that I put MovingPandas on the one hand side in QGIS, a project which I've been involved in for 17 years, and on the other side, explore something new, explore different big data warehouse options. In this case, I will be talking about Google BigQuery, which a partner from Carto has been implementing. So just out of curiosity, I can barely see you, but I think I can get a feel like who in here has used QGIS before? Maybe 20-25%. OK, thank you so much. So QGIS is an open source geographic information system that has been around for over 20 years already. And it's a really great application, a very popular tool for working with spatial data. And it's very extensible, particularly with Python, which is how I got into the whole thing, because the core application is C++, and that's beyond my means. But in Python, I'm very comfortable. And what you can see here is an example of movement data analysis and where it starts. In this case, it's from movement ecology, so you can see the patterns of migrating birds. It's multiple individuals over multiple years and how they travel between Africa and Scandinavia and everywhere in between. But just looking at these points, of course, will not tell you much of a story beyond that. So that's where the analytics parts come in. And with the plugin for QGIS that I built by wrapping around MovingPandas, you can actually do this analytics without writing code, and that's what I wanted to achieve. So what you get are graphical user interfaces where you can fill the necessary information to, for example, calculate the movement speeds and directions and to visualize them on the map, as you can see here. So the color will indicate the speed, and the arrowheads will show the direction. We can also already see a couple of outliers. Obviously, no bird is probably going faster than 100 kilometers per hour. But if you work with these kinds of data sets, that's to be expected. There's always some issues. So it gives you also a starting point for some cleaning exercises, I guess. We can also turn the points into tracks, which will be useful to find out like where does the movement actually start, where does it end. And then we can narrow down, we can drill in and look at individuals. For example, this one that started somewhere in northern Germany, close to Denmark, and always travels back and forth every year to different locations. And we can also run some more analytics on top. For example, where does it stop and for how long? So here you can see the stops visualized, and the larger the circle, the longer that bird stayed at the particular location. And that can also already be very, very helpful for the researchers. You can, of course, do that for all the individuals. You can then cluster and find hotspots of relevant stopping locations, which you might want to protect, as well as the corridors where the animals travel. But of course, we can do this for all kinds of other things. So in another research project, we didn't have animals, but we were interested in looking into public transport. And of course, in public transport, one thing that you have is the schedule, which is kind of static. And that's why I wrapped another library, which is called GTFS functions, which allows you to basically read those Google general transit specification feed files. Or now it's called, yeah, just general and not Google, but anyway. And you can read them, you can show them in QGIS on whatever background map that you like to get a better understanding, but also it will give you all the details about all the trips that have been scheduled. So during this time window, it's supposed to run with, the bus is supposed to run with this speed on exactly this segment between these stops. And what we wanted to do is we wanted to compare it with the actual GPS track of a bus that was driving there. So we got also the real-time feed and logged that. That was our partner from ULB, from Brussels. And they gave us these trajectories, and we then combined them. We looked on consecutive segments between stops, like you can see here. Every color is another segment of the trip of the bus. And then we built with the QGIS no-code model builder a workflow that allows basically every transport analyst to do this themselves. So they feed in the schedule, the GTFS segments on top, they feed in the real-time data, and what it will calculate is for every trip the delay between what was observed and what was scheduled. And then they can visualize it on the map, and many of them, they are quite good with working with QGIS, but they wouldn't be able to code this themselves. So that's definitely a step in the right direction, I think. So this plugin has been available on the QGIS plugin hub. This place has thousands of plugins contributed by all kinds of people, by professional developers, by enthusiasts, by researchers, and they are in various states. So you will find plugins that have been downloaded a few dozens of times. You will find plugins that have been downloaded hundreds of thousands of times. And it's really a great place to start if you're looking for functionality that doesn't come out of the box. And Tragic Tools is in there as well. For hosting, if you're curious, I've recently moved from GitHub to Codeberg for reasons. And well, basically I invite you to explore that option as well. It's a great alternative, and it would be great to have more people on there as well. I already said that desktop GIS wasn't the only topic that, or the only integration that I was looking into to make these tools more accessible. The other thing was to bring it to people who don't want to install desktop GIS, which is a large share of the people, to be honest. So in the recent project, in the Emeralds projects that we are working with Carto, which some of you might be familiar with if you've been in the geospatial space, they have been working on wrapping MovingPandas and bringing it to their cloud offerings, and particularly to another no-code environment. In their case, they call it workflows. And the concept is very similar to what we have in QGIS. Basically, you have these modular building blocks that you can assemble to a larger workflow to automate certain processes. And what they did is they implemented UDFs, wrappers around MovingPandas, and put them into the data warehouse implementations. So first, they started out with Snowflake, I think, because the Python UDFs there were the most advanced at that point, but recently transitioned to Google BigQuery implementation, which is, as far as I know, their main data warehouse offering, besides multiple others. So I have a short overview of how this no-code environment looks like, because I think it's pretty well done, and you can get a bit of a feel for like how users would interact with it. So again, we're starting out with, in this case, a table of points. Again, we are turning these individual points into trajectories, which they have decided to model like these temporal points, so always assigning the timestamp and the geography. And then you can do very similar things. We can also, again, detect the stops, find out, for example, the duration of the stop. We can compute different metrics, like the speeds, the duration, acceleration. And all this will be added to the points that we can then write back into a table in our data warehouse, and we can then visualize on the map. And this is a public data set that you can find on Kaggle. The Porto taxi data set is very popular. And in this case, we just show two different trips. One of the taxis really must have had a trip of their lifetime through half of Portugal. But yeah, basically, you can see here how we are visualizing the calculated speeds. We are visualizing the calculated stop. And very similar to what you saw in QGIS, you can get an insight into what's going on here, what might be interesting to look at, what might be odd, like this long trip I would have never expected in this data set. And yeah, so this is the second implementation that I'm at least partially involved with. And the third one, which I just want to briefly mention, I'm not even really personally involved with, but I find it so cool, that's why I'm mentioning it. It's MoveApps, which is built on top of the MoveBank platform by the Max Planck Institute of Animal Behavior, of all things. And they started out doing everything in R, but recently, or now I guess it's 2 or 3 years ago, they started also introducing support for Python, and they use the MovingPandas trajectory collection as their default I/O type for Python, which I find really cool. And basically, they also decided to do a no-code environment. And you can see here how they visualize all these boxes. I really like how they have all the intermediate results at the bottom of the box. So every time you run the thing, you can look at all the intermediate results. And they can be anything from a pickle file to an HTML file, whatever the algorithm happens to generate. And you can look at them, you can debug them, you can gain insights from that. So yeah, very nice no-code environments, hopefully user-friendly. It's definitely a step up from having to code stuff. But what about AI? Why don't we have an interface where we can communicate with these tools in natural languages? And well, let's say people are working at it. Actually, there have been a lot of great talks in the last 2 years about this topic of people who are trying to make this a reality. For example, in summer 24, we had the QGIS user conference in Bratislava, and we had this really great talk from the team that is developing the IntelliGeo plugin. This is one of the experimental plugins, so you will have to activate the Allow Experimental plugins if you want to give it a try in QGIS. And there's also a tutorial from the most recent conferences that you can try. What they started out doing is they actually wanted to automate creating these models, these workflow, the whole process from a prompt. So you tell, I want to know where the birds spend most of the time during their summer migration. And the goal was to generate this whole pipeline of all the building blocks. Recently, as far as I know, they scaled that back a little, and they first want to implement the Python scripts that can implement this whole thing, because it turns out that in the background, these models, these workflow files are really, really large, which basically is a problem for the large language models. But it's really exciting to look into, and you can actually give that a try with the tutorials that are out there. There's also another team around the Q plugin who are doing very similar things, so automating different analysis workflows. Basically, they have trained on the whole documentation of all the different building blocks that are available in QGIS to do analytics, to find a tool, develop a tool that can perform these analyses automatically. But it's not just LLMs. Of course, AI is also used in all kinds of other things. For example, it's used to help with different tasks of editing data, of actually geo-referencing data. Like if you have a scanned map, and basically your job is to turn this scanned map into a digital representation, you will be very happy if you have tools that support you. And another tool from this very group is an AI-supported vectorizer, which is supposed to help with actually making sure that the lines that you draw on top of a map are really as aligned as they can be, which is really cool, helping people to actually work better. Other ideas that have been floating around and have been implemented are, for example, AI assistants that help download data, for example, from OpenStreetMap, the INO plugin, which is very helpful because it can be tricky if you're not very deep into how OpenStreetMap data is organized to find out like what exactly do you need to download, whether it's points, lines, polygons, and how it is modeled and how you can get access. To example, for building data, or for points of interest data, or for road data. And last but not least, I think the most popular plugin that is machine learning AI, of course, is from the remote sensing community from Earth observation, the semi-automatic classification plugin, which is about classifying objects on imagery data in a supervised way. So there's a large range of AI and machine learning tools that are already being implemented, and some of them already used by really a ton of people. You can see over 2 million downloads. I find that very impressive. Tragic Tools is very far from that number right now. So coming back to the starting point, what makes an open source project successful? And I think clearly it's about the people. It's about all the people who go to these kinds of conferences and who share all these interesting developments and who inspire others maybe to try something and to give feedback. But of course, it's also the people who work in the background on the core application and who make sure that it's maintained, that it's updated. QGIS, for example, needs to take the step now from Qt5 to Qt6, which is a major overhaul in the back end, which nobody of the users is really excited for, right? But it's still an important step that has to be taken to make the project sustainable. So it's also these kinds of people who keep the project running. And of course, it is the users who provide the feedback, who lobby in their organizations to use QGIS, to support it financially, to support it with manpower, to support it with organizing events. So it's a large community that makes an open source project successfully, ideally. And it can start from a very modest background. So the first time I actually met many of these people in person was in 2009, when they happened to meet in Vienna. And I decided to, what the heck, I'm just gonna go there. I'm going to show up and let's see where this takes me. And well, here we are. And it's been a really great ride. It's been a great ride for all of us. I would say here you can see the trends since back then, 2009, compared to many of the proprietary commercial competitors. You can see QGIS is the blue line that's been closing up with the leading proprietary competitor, while the other one, well, basically has taken a nosedive. And if you're wondering about the spike, that is a COVID spike, because they had these dashboards that were in the news everywhere, but yeah, that's history. What does it take to build this community? Of course, these in-person events are important. Pizza is important. These are many of the locations where we had in-person meetings of the QGIS community. So yes, sustainability on the one hand side, I think it's important to be there in person. We are all aware of being a slight hypocrite on the ecological side with making people travel all over the world. But I think like meeting once or twice per year is actually very conducive to the project to talk about the difficult topics that you don't manage to talk on mailing lists. So I still think that it's important to have events like this where you can see people in person, where you can meet better, understand how their mind ticks. And that also makes it more easy to then do the digital communication, the asynchronous communication, which we all know is so difficult to get right and leads to many misunderstandings. We also often get asked, like, how many users does QGIS have? And it's difficult to answer. Many of you will know if you have a library or something, it's actually very hard to know, like, how many people use it, how often it's downloaded. We have some kind of idea, which you can see on the analytics.qgis.org site, because we can see usually, at least when people are online, when they open QGIS, it will connect to this plugin repository to check if there is updates for your plugins. And we can get a feeling of how many people open QGIS. And you can see this chart since we started logging in 2022. We have a nice growth curve to currently around 19 million monthly QGIS opens, which gives you an indication of about approximately where people are at. Most QGIS users use it in a professional setting, so they will not be working on the weekend with it very much, but Monday to Friday are really the busy times. So what I want to leave you with, we have all this vibe coding hype right now. I don't think this is where sustainable projects will end. I think what we need to do is we need to move thoughtfully, we need to build things, we need to take the best thing of what Gen AI and all the other tools can give us to support our users, to support the developer community, and to actually make the work of people easier and more enjoyable, and to bring the best results to the whole community, and to make it openly available so that everyone ideally can have access to the things that we're building. And if you're interested in exploring more geospatial, more GeoAI, see all the new things that are happening, I invite you to join the Spatial Data Science Symposium. It's hybrid, online, you don't need to travel anywhere. Registration is free. You can see what people are currently working on and what might be the next big thing, maybe in geospatial. And with that, I'm looking forward to the discussion and have a great second day of the conference. Thank you.
Thank you, Anita. Are there any questions? We have time for a few. Yeah.
Thank you very much for the great presentation. I found it interesting that in your field of data science, the graphical interface is very important, and therefore non-programming interface are interesting. And you mentioned that you have the options of desktop and cloud-hosted solutions to address this need. But cloud hosting can be expensive, and desktop requires manual installation on your local machine. Have you explored the possibility to use a WebAssembly to have a mix between the two, and have been there successful attempt at this?
Yes, that's a very good question. Thank you. Actually, there is a QGIS version that's works with WebAssembly, which is still mind-blowing for me that they managed to do that. Of course, it's not perfect yet. It takes a long time to load because QGIS is a large project, but there are developments going on. And if you're interested, I can get you, it's on GitHub. You can find the sources online. It's a Swiss group that is working on that. Also, there are users who have figured out like how to do organization-wide rollouts of QGIS, and there are like guidelines so that not all of your users have to install it manually, which also helps in large organizations. But WebAssembly is an interesting thing that is actually being explored, yes.
Any other question? I have one. Is there a QGIS plugin for the pizza plots, or is this manual? But more serious question though. Like the people working on the core, with transitioning from Qt5 to Qt6 and all, who is paying that? What are the main sources of funding? How does that work for QGIS?
Yeah, that's an important question. So the financing of the QGIS project is all sustaining members and donors. So what we set up is an organization hosted in Switzerland, and large organizations and our user groups. Actually, we have like dozens of national user groups. They become members of this association, and they support financially the sustainability of the project. So you can find online the current budget numbers. If I'm not completely mistaken, last year was somewhere between 400 and 500K for the association, which we invest largely in bug fixing drives and in all kinds of maintenance and improvements of the project infrastructure. So this is what pays these behind the scenes updates of the core. But of course, the whole QGIS application wasn't built using the funding of just our association. All of the feature development is either individuals who contribute their time as volunteers, or more likely it's developers working for professional companies that provide QGIS development services to their clients. There's like more than a dozen companies that have core contributors who can do that and who will develop whichever functionality is necessary for their clients. And we have processes, QGIS enhancement proposal processes for synchronizing between the different developer teams and for deciding like what is the best avenue for how to implement a certain feature if it's a larger thing that influences the application and might change things under the hood. So this is how it's working. A lot of funds go directly from the people who need a new feature to the developers without ever touching the QGIS organization. But for the really behind the scenes, which no individual user is going to fund, like going from Qt5 to Qt6, the users don't care. That is where the funds from the association come in, which are provided by sustaining members and by donors.
Any other question? All right, thanks. Anita, please give her another round of applause.
Thank you.